So package Java sort. So we're using the sorting method. Then import java.util.scanner. It means we're using the scan. Then this time we're using the public class Java sort for our main class. Then public static scanner sc is equals to new scanner open parenthesis system n dot system dot in close parenthesis. Then public static void main open parenthesis string arg then close int n. So and then next is system dot out dot print enter size of an array. So we will print out the enter size of array. Then int a is equals to new int. So this time we will print out we'll use the system dot out dot print enter unsorted elements. Enter unsorted for open parenthesis inti is equals to 0. Well, I is less than n, then I increment. So then system.out.print elements before sorting. So we'll print out the elements before sorting. So for inti is equals to 0 while I is less than and then I increment. And then we will print out the then system.out.print element using sorting selection. So we will use the system out.print to print the elements using selection using elements using selection sort open parenthesis a close parenthesis for then open parenthesis inti then a then close parenthesis sort ob is equals to new sort. Then next is system.out.print elements using merge sort. Then ob.merge sort open parenthesis a 0 and -1. Then for open parenthesis int I then a system.out.print open then we will print out the I. Then system.out.print ln system next is we use the public static voids selection sort intr array for inti is equals to 0 while I is less than array length -1 then I increment int index is equals to I. Then for open parenthesis int g is equals to I plus 1 well g is less than array length then g increment. If array g is less than array index is equals to g, then int smaller number is equals to array index is equals to array I, then array I is equals to a smaller number. Class sort we're using the class sort. Then void merge int array then int p int q and int r. int n1 is equals to q minus p plus 1. Then int n2 is equals to r minus q. Then int l is equals to new int n1. So int m new int into. It fill the left and the right array. Then for int I is equals to 0, int I is less than and 1, then I increment. Then for 4, then int g is equals to 0, while g is less than negative n2 and g increment. mg is equals to array q plus 1 plus g. It maintain current index of subarrays and main array. Int I, j and k. I is equals to 0, g is equals to 0, k is equals to p. Until we reach the either end of either L or M, pick larger among elements L and M and place them in the correct position at A, P, R for sorting and in descending. While I is less than N1 and G is equals to I is less than N2. If L is less than or equals to M, then array K is equals to L. Then I increment. Else, array K is equals to M, then J increment. When we run off the elements either L or M, pick up the remaining elements and put it in the array. Then, while I is less than N1, array K is equals to L. Then I increment and K increment. While J is equals to N2, array K is equals to M. Divide array into two subarrays, sort them and merge them. Void merge sorts. Int array, then int left and int right. If left is less than right, M is the point where the array is divided into two subarrays. Int mid is equals to left plus array, plus left plus right. Recursive call to each subarrays. Merge sort array left and mid. Merge sort array mid plus 1 then right. Merge the sort subarrays. Merge array left, mid and right. Then we will run the code. Enter the size of the example, magkwantag 5 ka elements. Then enter the 5 unsorted elements. Then let's try 1, 3, 5, 2, and 4. And then this is the final result. Elements before sorting is 1, 3, 5, 2, 4. Then elements using selection sort, then there nag-select na siya. So gihimo siyang sorted. So 1, 2, 3, 4 and 5. Then elements using merge sort. So mo na siya ang final output. 1, 2, 3, 4 and 5.